What is up, ChemStars? In today's video, me and my partner Shreyas and I, Phoenix, are going to be doing stoichiometry. Alright guys, for the first step to doing stoichiometry, we have write a balanced chemical equation. So, the equation that we were given, or the question we were given, is methane burns with oxygen to produce carbon dioxide and water vapor. So if we look at the equation, we have 1 CH4, 3 O2 equals 1 carbon dioxide plus 2 water vapor. Step 2 of stoichiometry learning. You guys have to calculate the number of moles given. So, in the question, we were given 2.15 grams of methane. So we have to convert that to moles. How do you convert that to moles, Shreyas?
You find the molar mass of methane.
There you go, you heard the man. Molar mass. So as you see, we put molar mass on the bottom because we want to find the moles. So you put 16.05 grams of methane on the bottom, multiplied by 2.15 grams of methane as well, which equals 0.134 moles of methane.
What is up, guys? I'm taking over from Phoenix and we're learning about stoichiometry step 3. For this one, we're applying the mole ratio unknown over given to determine the moles of the unknown substance. For this, we have the mole of CH4, which is 0.134, times that by the mole ratio of 1 mole of CO2 over 1 mole of CH4. That equals 0.134 moles of CO2.
And Shreyas, why do we put the substance next to the numbers?
To get that ChemStar sticker.
Yeah, good communication equals good marks.
Oh yeah. Alright guys, now we're at step 4. Calculate the quantity required for volumes of CO2. We're finding liters. So first of all, we find the molar mass of methane, which is 1 mole of methane over 16.05 grams. And then multiply that by the mass given, which is 2.15 grams, and over 1. Times that by the mole ratio, which is 0.134 moles of CO2, divided by 0.134 moles of CH4, and then times that by 8.314 times kPa times liters, divided by moles times K, Kelvin. Then times that by 2.73 kelvins that was given for CO2, divided that by 101.325 kPa CO2, which was given for CO2. The molar mass is right here, and the answer is 3 liters.
Alright, Shreyas, do you want to show us how to cancel out?
Alright, Phoenix.
Let's cancel out the units so we know what we're getting, Shreyas.
Alright, so we've canceled out the grams right here.
Nice.
Then the moles of CH.
Okay.
4. And then we have kPa right here.
Yep.
Kelvin. Moles right here. CO2. And we have liters left. And we just do the multiplication and you get 3 liters.
Sounds good, Shreyas. Alright, now that you know all 4 steps, let's do a quicker review. First, calculate the balance equation. Second, calculate the number of moles that you need and that are given. Third, apply the mole ratio, it's always unknown over given, to determine the number of moles of the unknown substance. Alright, and step 4, calculate the quantity required. In our case, we need liters. A few quick tips before you get into this. Make sure you always write the info you have. So in our case, we had 2.15 grams of methane and 101.325 kPa of CO2 and 273 Kelvin of CO2. In other words, this STP. And what we needed was volumes. On the right here, we also have molar mass of CH4. So you see we have C equals 12.01 and H4 equals 1.01 times 4, which gives you a total mass of 16.05 grams over moles.